Hi friends, welcome to Mallesham Creations. Welcome to Mallesham Creations. Today's topic is nucleophilic substitution reaction. So we will see what is nucleophilic substitution reaction today. So usually nucleophilic substitution reactions are performed by alkyl halide, that is for example methyl bromide. When methyl bromide is reacted with strong nucleophile like OH- produces methanol. This is methyl alcohol plus Br minus. That means what is happening? Br is replaced with the OH minus. This is the example for nucleophilic substitution reaction. Therefore, first of all, what is substitution reaction? The replacement of one atom or group with another atom or group is called as substitution reaction. If that atom or group is the nucleophile, then that is known as nucleophilic substitution reaction. So finally, how to define means the replacement of a weak nucleophile with a strong nucleophile is called as nucleophilic substitution reaction. Nucleophilic substitution reactions are two types in chemistry. One is unimolecular nucleophilic substitution reaction and the second one is bimolecular nucleophilic substitution reaction. Unimolecular nucleophilic substitution reaction is also known as SN1 reaction. Bimolecular nucleophilic substitution reaction is also known as SN2 reaction. Usually this SN2 reaction I compared with Bahubali reaction, Bahubali climax scene that was already made a separate video and uploaded. If you want more details, please watch that one. But here also I can clearly explain what is SN1, what is SN2. So first we will discuss SN1 reaction. What is SN1 reaction? It is the unimolecular nucleophilic substitution reaction. SN1 means in the SN1, S means substitution, N means nucleophilic, 1 means unimolecular. Therefore, this SN1 is also known as unimolecular nucleophilic substitution reaction. In SN1 reaction, the rate of reaction depends on only the concentration of alkyl halide but not on the nucleophile. Therefore, the rate is directly proportional to only concentration of alkyl halide. That means the concentration of alkyl halide can decide the rate of the reaction. Since the rate is depending on only alkyl halide, that is only one component, therefore this is the first order reaction. SN1 reaction, the mechanism of SN1 reaction proceeds in two-step process. However, SN2 reaction proceeds in a single step, will be discussed later. But you should remember this one that SN1 reaction proceeds in a two-step process. In the SN1 reaction, the intermediate is what means carbocation. Carbocation is the reaction intermediate in SN1 reaction. Whereas in SN2, it is the transition state that will be discussed later. In SN1 reaction, this kind of reactions are favored by polar solvents. SN1 reaction is favored by polar solvents. In this, what is the resulting product means 50% of inversion and 50% of retention product is formed in SN1 reaction mechanism. What is inversion? What is retention product means? If the configuration of the product is similar to that of the starting material, that is called as retention of product. If the configuration of the product is opposite to that of the starting material, it is known as inversion product. Then what kind of, usually alkyl halides participate in nucleophilic substitution reaction, but alkyl halides are different types. For example, tertiary, secondary, primary alkyl halide. Then what kind of alkyl halides participate in SN1 reaction means tertiary alkyl halides participate in SN1 reaction compared to secondary and primary. But tertiary alkyl halides favors the SN1 reaction mechanism. Now we will see what is reaction. For example, tertiary butyl bromide I have taken here. This is the tertiary butyl bromide because this is called as tertiary carbon because it is attached to 3 carbon atoms. When a carbon atom is attached to 3 carbon atoms, it is known as tertiary carbon. This is entire molecule is called as tertiary butyl bromide. When tertiary butyl bromide reacted with the hydroxide ion, this is a strong nucleophile, then this Br can act as weak nucleophile because bromine electronegativity is more than the carbon. Therefore, this can make a partially negative charge. This can make a partially positive charge. Then overall, this Br minus can be replaced with the OH minus. In presence of polar solvents, this reaction occurs. The resulting product is tertiary butyl alcohols. So 50% of retention product, because where the bromine is there, exactly the bromine is replaced with the OH. Therefore, this is called as 50% retention product. However, this is the 50% of inversion product, because this bromine place is almost, OH place is almost opposite to that of the bromine place. Therefore, this is the 50% inversion product. So why 50% retention product and 50% inversion product in SN1 reaction mechanism? That can be clearly explained by reaction mechanism. So now we will see what is reaction mechanism. Coming to the reaction mechanism, as we already discussed, this SN1 reaction proceeds in two-step reaction mechanism. In that, first one is formation of carbocation. We already discussed that the reaction intermediate in SN1 reaction is the carbocation intermediate. How carbocation is forming means, first take tertiary butyl bromide. Tertiary butyl bromide in presence of polar solvents can be converted into the carbocation and Br minus. When polar solvent is added to tertiary butyl bromide, this can be converted to the carbocation. This is the carbocation intermediate. As we already mentioned that carbocation intermediate is the reaction intermediate in the SN1 reaction mechanism. Here we have to remember that tertiary butyl bromide is the tetrahedral geometry. In this, the bond angle between the carbon and another carbon is the 109.5 degrees. But when Br minus is removed from the tertiary butyl bromide, this carbocation intermediate is having the planar geometry, from tetrahedral geometry to the planar geometry. This carbocation is having planar geometry, and the bond angle between the carbon atoms is 120 degrees. Since it is the planar geometry, the attacking nucleophile can attack from the front side or back side. Same possibility is there because this carbocation intermediate is having planar geometry. When the planar geometry is there, the attacking nucleophile can attack from the front side or the back side. Both possibility is same. 50% possibility is there. Therefore, the resulting product is like that. We'll see. The second step, the attack of nucleophile on carbocation. Just take this carbocation intermediate. OH minus is the nucleophile. This can attack from the backside of the carbocation. When the nucleophile is attacked from the backside of the carbocation, the resulting product is the 50% inversion product. This is the inversion product because the OH position is opposite to that of the bromine position. Therefore, this is the inversion product. This is very fast step. When OH minus is attacking from the backside of the carbocation. However, the OH minus, that is a strong nucleophile, there is a possibility to attack from front side also. Similar possibility is there. Therefore, if OH minus is attacking from front side, what is happening? What is happening? 50% retention product is formed. That means where the bromine is there, exact in that position, OH is substituted. Therefore, this product is known as retention product. That's why in SN1 reaction mechanism, 50% inversion product and 50% retention product is formed. This is about the SN1 reaction. Next, coming to SN2 reaction. If you understand very well SN1 reaction, SN2 is very easy. Because in SN2 reaction, S stands for substitution, N stands for nucleophilic, 2 means bimolecular. Therefore, this SN2 is also known as bimolecular nucleophilic substitution reaction. The second point is SN2, the rate of reaction depends on both factors, that is alkyl halide as well as nucleophile. The rate of reaction depends on two factors, that is the concentration of alkyl halide as well as the nucleophile. Therefore, this rate is directly proportional to alkyl halide as well as nucleophile concentration in SN2 reaction. Therefore, the rate is depending on two factors. It is a second order reaction. SN2 reaction proceeds in a single step, whereas SN1 proceeds in two steps, but SN2 proceeds in a single step reaction mechanism. SN2 reaction, the reaction intermediate is the transition state. However, in SN1, carbocation is the reaction intermediate. In SN2 reaction, a transition state is the reaction intermediate. SN1 reaction is favored by polar solvents, but SN2 reaction is favored by nonpolar solvents. The resulting product is 100% inversion product in SN2 reaction mechanism. However, as we have seen in earlierly, in SN1, 50% retention and 50% inversion product is formed. But in SN2, 100% inversion product is formed. But what is inversion product means? If the configuration of the product is opposite to that of the starting material, it is called as inversion product. If the configuration of the product is similar to that of the starting material, is called as retention product. If the configuration of the product is opposite to that of the starting material, is called as inversion product. In SN2 reaction mechanism, 100% inversion product is formed. But in SN1 reaction, 50% retention, 50% inversion product is formed. Then what kind of alkyl halides participate in SN2 reaction means primary alkyl halides participates in SN2 reaction mechanism. This is about the SN2 reaction. We'll see example of SN2 reaction mechanism. As we discussed earlier, the primary alkyl halides participate in SN2 reaction mechanism. This methyl bromide is an example for primary alkyl halide. When this methyl bromide reacted with OH minus hydroxide ion, this methyl alcohol is the resulting product and Br minus. That means bromine is a weak nucleophile is replaced by the strong nucleophile, that is the hydroxide ion. This is an example for SN2 reaction. So we will see the reaction mechanism. How this reaction proceeds means, take this methyl bromide. When methyl bromide is reacting with OH minus, that is a strong nucleophile, this strong nucleophile can attack from the backside of the leaving group. Here bromine is the leaving group. This OH minus can attack from the backside of the leaving group because this backside of the leaving groups hydrogen atoms are there. Hydrogen atoms are having very smaller size. Therefore, this OH minus, which is a strong nucleophile, can dominate and go and hit the carbon atom. Like this, OH minus can attack at the carbon which is opposite to that of the leaving group. That time what happens? A transition state is formed. That means 3 hydrogen atoms are attached to the carbon, OH is partially bonded to the carbon and bromine is partially bonded to the carbon. Almost 5 bonds. It is impossible. Usually carbon should have only 4 bonds. But here it is having partially attached to hydroxide and partially attached to bromine. This state is called as completely transition state. This step is the slow step in this SN2 reaction mechanism. Once transition state is formed, transition state is highly unstable. It cannot survive for a long time. Therefore, automatically it will convert into corresponding alcohol, that is methyl alcohol. However, the configuration of the product is almost opposite to that of the starting material. Therefore, this product is inversion product. 100% inversion product is formed in SN2 reaction mechanism. However, in SN1, 50% retention and 50% inversion product is formed. But in SN2, 100% inversion product is formed. This usually I compare with Bahubali for easy understanding to my students. Usually old tradition is to compare with umbrella, but it is very old for me. That's why I want to compare with Bahubali, which is a new trend. So I hope you will enjoy this comparison and you will remember for a long time. Because here in Bahubali climax, in what is happening, Kattappa is attacking from the backside of the Bahubali. So to attack from backside, it is taking very long time, almost 4 to 5 years. Similar to Bahubali movie, in this SN2 also same. OH minus should attack from the backside of the leaving group, that is Br. But it takes lot of time and it is the slow step and it is the rate determining step. After attacking Kattappa to Bahubali, few seconds, complete silence. That means it is called as transition state. No one understood what is going on, why it is happening like that, why Katappa is attacking to Bahubali. It is surprise to everyone. Similar to this, here in SN2 reaction, one transition, this state is called as transition state because usually we know that carbon should have only 4 bonds, but here carbon is bonded with 5 atoms or groups because OH is partially bonded to carbon, Br is, which is a leaving group, is partially bonded to the carbon. Already 3 hydrogen atoms are covalently bonded to this carbon. This state is called as transition state. After formation of transition state, here what is happening? Katappa will remove this sword from the Bahubali. Finally, what happened here? Bahubali is sit opposite to his opposite direction to his original direction because at beginning he is standing towards right side, but here in this scenario he is sitting opposite to that of his original position. Similarly, here also the configuration of the product is opposite to that of the starting material. Therefore, I compare with Bahubali. So finally, what is happening? OH minus nucleophile is attacking from the backside of the leaving group. Then a transition state is formed. This state is highly unstable. The formation of transition state is the slow step or rate determining step. After formation of transition state, immediately it will convert into corresponding alcohol with 100% inversion product. But you may have some small doubt because in SN1 also we wrote like this only. One is slow step, second one is fast step, but carbocation is the reaction intermediate. That I said two-step reaction mechanism. But is in SN2 also I am writing like 2 steps, but I am telling only single step. You may get that doubt. So for that, what is the reason means in SN1 carbocation is the intermediate that is highly stable. We can isolate that carbocation and analyze also. But this transition state is just imagination. This may form like this. We cannot separate this from the reaction. We cannot isolate this transition state molecule. Simultaneously, it will convert into the product. That is the difference. Just for understanding, we are showing in 2 steps, but this is not 2 step. This simultaneously occurs from methyl bromide to methanol formation. This OH minus directly attack from the backside of the leaving group. Immediately the bromine can leave. But to understand the reaction mechanism, we show this transition state that you should remember. So finally, what are the differences between SN1 and SN2 reaction means? SN1 reaction, S stands for substitution, N stands for nucleophilic, and 1 stands for unimolecular. Therefore, SN1 reaction is also known as unimolecular nucleophilic substitution reaction. However, in SN2, S means same substitution, N also same nucleophilic, but 2 means bimolecular. Therefore, this SN2 reaction is also known as bimolecular nucleophilic substitution reaction. SN1 reaction, the rate of reaction depends on only alkyl halide concentration, but not on the nucleophile. That means the conversion of reactant to product that can be decided by only the concentration of alkyl halide. Nucleophile cannot affect the rate of reaction in SN1 reaction mechanism. Therefore, the rate is directly proportional to the concentration of alkyl halide. However, in the case of SN2, the rate can be decided by 2 factors. One is concentration of alkyl halide. The second one is nucleophile. That means both can decide to convert from starting material to product. That rate can be decided by 2, that is alkyl halide as well as the nucleophile. Therefore, the rate is directly proportional to alkyl halide and nucleophile in SN2 reaction mechanism. Since the rate is depending on only one component, it is a first order reaction. However, SN2 reaction, the rate is depending on 2 components. It is called as second order reaction. Next, SN1 reaction proceeds in 2-step mechanism that we have seen clearly. One is the formation of carbocation. After that, attack of nucleophile. But in SN2 reaction, this reaction proceeds in a single step, that is the formation of transition state. A carbocation is the reaction intermediate in SN1 reaction mechanism, but a transition state is the reaction intermediate in the SN2 reaction mechanism. Next, SN1 reaction can be favored by polar solvents like methanol, DMSO, and DMF, etc. However, the SN2 reactions can be favored by non-polar solvents like hexane, benzene, toluene, etc. SN1 reactions are favored by polar solvents. SN2 reactions are favored by non-polar solvents. Next, SN1 reaction, the resulting product is 50% inversion, 50% retention product is formed. But in SN2, 100% inversion product is formed, as we have seen in the reaction mechanism. Next, the last point, coming to SN1 reaction mechanism, what kind of alkyl halides perform SN1 reaction means tertiary alkyl halides participate in SN1 reaction mechanism. However, the SN2 kind of reaction can be followed by primary alkyl halide. This is the main difference between SN1 and SN2 reaction. Hope you enjoy this video. If you like this video, please like, share, comment and subscribe. Thank you for watching. Bye bye. Have a good day.